Okay, so as we talk about respiration, one of the most important things to respiration is Fick's law. And you don't necessarily need to know it by that name, but you do need to know what it means. So Fick's law means that the flow over time of a molecule that's diffusing is related to its diffusion coefficient times the surface area of the membrane that it is interacting with times the concentration gradient of the stuff. Okay, so what this means is that if we've got a big surface area, we're going to have better diffusion or a better rate of diffusion. And if we have a greater concentration difference between the two sides, this means a greater diffusion. Now, of course, there are parameters about the molecule that's going to affect this. And this is this D here, and this can be molecule size and interactions. Now, it turns out that what we can do with Fick's law is we can actually combine it. And when we combine it, we can go ahead and combine it with rules surrounding solubility. And there we get something that looks like this. Where the diffusion rate equals, we've got D, which again is our diffusion coefficient times the surface area of the membrane times the partial pressure of a gas, which is the amount of gas in the environment, times the solubility of the gas, so how well it moves around in that environment. And this gets divided by x. This is going to be the distance, times the molecular weight, the square root of molecular weight. So basically a bigger molecule would be bigger here. It's going to have a slower diffusion rate. A bigger distance is going to have a slower diffusion rate because it's going to be a larger number that we're going to divide this by. All right, so what does this then have to do with anything? Well, one example of where we can use this is we can use these solubilities, or this solubility and partial pressure, to talk about breathing. So if you go up to altitude, you're going to have a lower partial pressure of a gas. Now, if you have a lower partial pressure of a gas, what happens to the diffusion rate? Decreases diffusion rate. So it makes it harder to get oxygen, which is why the air at altitude seems thin. Okay, now let's compare water animals versus land. And it turns out that oxygen has a low solubility. This means that in water, oxygen has a low diffusion rate. Okay, I'm going to go one further. Now I'm going to take a second and I'm going to talk about this distance here. If you are, I'm going to just sort of approximate animals with spheres, if you can believe that, that is such a physicist thing to do. Here's an animal with an open circulatory system. So a molecule of oxygen to get into that animal is potentially going to have a long distance to travel. If instead we have an animal with a closed circulatory system, so they've got a system of vessels in there, now for a molecule of oxygen to get in, it's going to get in and then it's going to flow with the blood. And it can get anywhere. And it's the same distance to travel, but it's going to get to near the tissue that it needs to go to very, very quickly. And then it can diffuse out of the vessel and get the rest of the way to where it needed to go with basically a very short diffusion distance. This means it's going to do it really fast. So most of your animals that are really active are going to have a closed circulatory system, but if you look at active animals, something very, if you look at insects, something very different happens. And that's that if we look at an insect and we've got the tissue that needs oxygen, I'm just going to kind of draw it like a muscle, okay? In a normal closed system, a blood vessel would go by this tissue, and if the blood vessel goes by that tissue, the blood is able to diffuse into the tissue where it's needed. Well, that's not the case with an open system, right? With an open system, what's going to happen is now that molecule is going to have to diffuse all the way to the tissue, and that can create some amount of problem because it's not going to be able to take the shortcut of using the circulatory system. So what insects do is actually really, really interesting. They have these tubes that are called trachea. And the trachea are almost like a system of vessels, but they're like a system of vessels that are only filled with air. They're not filled with any kind of blood or anything. And since those tubes come nearby active tissues, now when this oxygen molecule wants to get to that active tissue, it's got a much shorter diffusion distance. So this is why insects are actually able to have that open circulatory system but still function with a high activity level. It's because they're relying a lot less on diffusion. And remember, diffusion is really, really, really slow. So if you're an animal that wants to be active, you're going to use a lot of oxygen. And if you're relying on diffusion, that's just not going to work because it's going to be hard for you to get the oxygen that you need fast enough. If you cut down that diffusion distance, now that diffusion's happening fast enough that you actually can rely on it.